This lockstep model is unbelievably efficient, as long as everyone is doing the same thing. But it brings up a really fascinating question. What happens when your code has a branch? What if some workers in that crew need to do one thing, and the others need to do something completely different?
Just imagine your code looks something like this. It's a simple if-else statement. It tells the first 16 workers in the crew to follow one path, path A, and the last 16 workers to follow a different one, path B.
And this perfectly illustrates a major performance trap called warp divergence. Because the whole crew has to move in lockstep, the hardware handles this by running both paths, one right after the other. So first, the 16 workers on path A do their thing, while the other 16 just sit there, idle. Then the 16 workers on path B do their work, while the first group waits. The result? You've just slashed your efficiency in half. 50% of your crew is doing nothing at any given moment.
So, knowing about these constraints, like warp divergence, how does the GPU's management layer organize all these teams and workers to squeeze every last drop of performance out of the hardware?
Let's circle back to that really important rule we talked about earlier. A team of workers, a block, is always stuck on a single factory floor, or SM. There's a very, very good reason for this, and it all comes down to the speed of communication.
This table tells the whole story. Just look at the access speeds. Data that's stored locally, right there on the factory floor, in what we call shared memory is incredibly fast. We're talking about 23 clock cycles. But if a worker has to go all the way to the main warehouse, what's called global memory, it takes almost 300 cycles. That is a massive slowdown, more than 10 times slower.
And this chart really just drives that point home. The difference in performance is, well, it's dramatic. If your teams had to constantly walk off their factory floor to go fetch tools and materials from the main warehouse, the whole project would just grind to a halt. It would be a huge, unavoidable bottleneck.
So this is why that rule is so important. Keeping a block on a single SM guarantees three things. They get access to that lightning-fast local memory, all the workers can coordinate with each other basically instantly, and it just makes the scheduling job for the hardware way, way simpler. It's a design choice that is all about maximizing speed.